Hello, welcome to our series where we cover the questions in the WASSCE 2020 Dec Core Maths Paper 1. In this video, we're going to cover questions 11 to 20. Question 11 says, given that 3x plus 2y equals 19 and x plus y equals 8, find the value of y. One thing we can do is to eliminate x from this first equation. And we can do that by multiplying this second equation by 3. When we do that, we get 3x plus 3y equals 24. Having done that, we can now subtract this new equation from the one on top, which is 3x plus 2y equals 19. When we do that, we get minus y equals minus 5. That means that y equals 5. So that's our answer. The next question, that's question 12, says, find the quadratic equation whose roots are minus 2/3 and 4. Now, knowing the roots, we can recover the quadratic equation by remembering that we are looking for two binomials which multiply to give you 0. So the first one is going to be this, x plus 2/3, because you want it to be such that whatever is inside here, when you set it equal to 0, you're going to get that. So if x plus 3 is 0, then x must be equal to minus 2/3. And then for the second one, we're going to have x minus 4. If x minus 4 equals 0, then x must be equal to 4. So we expand this equation. This is the equation, but now we are trying to get it into one of these 4 forms that they've given us. So let's just multiply. When we do so, we get x times x is x squared, x times minus 4 is minus 4x, 2/3 times x. We now have plus 2/3 x, and then we have minus 8/3, that is equal to 0. We want to get rid of the fraction, so we can multiply through by 3. When we do that, we get 3x squared minus 12x plus 2x minus 8, that's equal to 0. We now simplify further to get 3x squared minus 12x plus 2x, that's minus 10x, and then we have minus 8, and that's equal to 0. So that's our equation, and that is D. The next question is question 13. It says the diagonals of a rhombus are 16 centimeters and 12 centimeters. Find its side. Now, the property of the rhombus we're going to use is that the diagonals of a rhombus bisect each other at 90 degrees. So the diagonals always bisect each other. Bisect means that now this length is equal to this length, and this length equals this length. So when you have a rhombus, this is how it looks like. Now we are told that the diagonals are 16 and 12. So if we take the longer one as 16, then this side is 8, this side is 8, and then the shorter one as 12, this side is 6 centimeters, this side is 6 centimeters. Actually, to be correct, let me distinguish these two lengths from each other. So the one with 3 strikes is equal to the one with 3 strikes, and then the one with 2 strikes is equal to the one equal in length to the one with 2 strikes. So with this setup, we now have a right angle triangle with sides 6 and 8. So we are supposed to find the hypotenuse, and you should know this triangle. It's a famous triangle. If you have a triangle, a right angle triangle whose legs are 6 and 8, you should automatically know that the hypotenuse is 10. This is just a rescaling of the famous 3, 4, 5 triangle. Sorry. If you have a triangle with legs 3 and 4, then the hypotenuse is 5. But of course, you can always use Pythagoras theorem. So Pythagoras theorem says that this length is equal to the square root of 6 squared plus 8 squared. Now the square root of, the square of 6 is 36, and the square of 8 is 64. And 36 plus 64 is 100. And the square root of 100 is 10. So that's our answer. The next problem is question 14. We're supposed to simplify this fraction. It looks pretty long, but let's see what we can do. Normally you can write the whole thing over one denominator, and in this case, if we notice that 1 minus t squared, so 1 minus t squared is a difference of two squares in particular, it's equal to 1 minus t times 1 plus t. So if you realize that, then you can see that actually you can write the denominator as this, and that's going to be the common multiple we're going to use. It's a convenient common multiple to use, so you can use that. It's equal to that, so you bear that in mind as well. So if you write 1 minus t squared here, then how do you write this first one? 1 minus t divides 1 minus t squared to give 1 plus t. So you now have t times 1 plus t. So you have t times 1 plus t. And then you have this minus t over 1 plus t. 1 plus t divides this to give 1 minus t. So you have 1 minus t here. And then you have plus 2t. This divides that to give 1, so there's nothing to do there. Then you continue, you expand the numerator, you get t plus t squared minus t plus t squared plus 2t all over 1 minus t squared. Now what is this equal to? This t and minus t will cancel out. Then we have t squared plus t squared, which is 2t squared. Then we have 2t plus 2t over 1 minus t squared. Now here we can factorize the numerator. We can bring 2t out to get t plus 1 all over 1 minus t squared. Now if you recall again that 1 minus t squared is equal to 1 minus t times 1 plus t, and 1 plus t is the same as t plus 1, then you can simplify this as the t plus 1 will cancel 1 minus t squared to give 2t over 1 minus t. So looking at the options, our answer is B. The next question is question 15. It says, if 16x squared plus mx plus 1 is a perfect square, find the value of m. Now this is a quadratic, and we know that, well, a perfect square means that you have binomials multiplying each other. For instance, if it's ax plus b, then you have ax plus b times ax plus b. So you are looking for something that will go here and the same thing goes here. Now, knowing that you are looking for two binomials that are the same and they must multiply to give you 16x squared, you want to find the square root of that 16x squared, and the square root of that is 4x. So you're going to have 4x here and 4x here, so that when you multiply, you're going to get 16x squared. And then over here too, you have plus 1. So you are looking for something that when multiplied will give plus 1. And it can be minus 1. It can also be plus 1. Plus 1 is easier to deal with. So this is what we have: 4x plus 1, 4x plus 1. Now let's multiply to see if we're going to get this 16x squared and so on. So 4x times 4x, that's 16x squared. Then we have plus 4x plus 4x plus 1. And this is equal to 16x squared plus 8x plus 1. This means that m is now equal to 8. Now, because we found the answer in the list, we don't bother about the other possibilities, but there are other possibilities. For instance, like I mentioned, you could have had 4x minus 1 times 4x minus 1. When you do that, here too you'll get 16x squared, but this time you get minus 8x plus 1. So all kinds of possibilities, and the point though is that with this one that we chose, we found one of the answer options. Whatever it is, it's going to be some multiple of, not some multiple, it's going to be some incarnation of 8, plus 8 or minus 8. All right, the next question is question 17. No, let's question 16 first. Question 16. Question 16 says the sets Q and R are represented on the number lines shown. Find Q intersection R, or Q intersect R. So we have Q that's shown as minus 2 to 4. So if you wanted to write this using this notation, you could write is a set of all x such that x is between minus 2 and 4. And then this set is going to be all x such that x is between minus 1 and 3. Now you want to find the intersection. One thing to notice is that the set R is clearly a subset of the set Q. Now in general, when you have two sets and one is a subset of the other, so you have sets, let's say the bigger one is set A and the smaller one is set B. When you want to find the intersection of two sets like that, the intersection is precisely the smaller set, because the intersection of A and B means that find all the things that are in both A and B. Now, if for something to be in both A and B, it must first be in B and then also in A, but everything in B is in A, so we are left with B alone, and that's the result. So now that we have two sets that R is a subset of Q, the intersection is actually R. So given that this is R, that's the answer we're looking for. If you want to see the other options, let me bring them up. So A, B, C, D, and the answer is A. The next question is question 17. It says, from the diagram, which of the following is true? Well, we have triangles with angles in them. One thing we do know is that for a triangle, the sum of this angle and that angle and that angle is 180 degrees. And we also know that because these two angles are on a straight line, this T and this angle, their sum is 180. So in particular, we can write that this angle equals 180 minus T. Similarly, these two angles add up to 180. So we can write this one as 180 minus S. All of this is degrees, 180 degrees. So having written these two this way, we can now write that the sum of the three is 180. So R plus 180 minus T plus 180 degrees minus S. This is all equal to 180 degrees. Ooh, don't let me write the 180. Okay, so we further simplify. We have 180 plus 180, that's 360, but if we want, we can also just cancel. We have 180 here and here, so they just go away. You subtract 180 from both sides. Then on the left side, you're now left with 180 degrees. So let me write 180 degrees plus r minus t minus s equal to 0 degrees. Now we have to look at our options to see which one does it look like. It doesn't look like this, because to get this, you have to have the 180 on one side and then all the RT and S on the other side. But if you do that, R is going to be negative, so that's out. This one is also out. It doesn't really have any 180. T minus S equals 180 minus R. That also doesn't work, because to get minus R, we have to take the R to the other side, and then to get 180, when you take the R to the other side, you have the 180 on the left and the minus R on the right, so you can't have the two of them on the same side with these signs. So we're left with D, and D says 180 degrees plus R equals T plus S. So let's see if we can rearrange this. And indeed, if we write 180 degrees plus R, and then we take the T and the S to the other side, that's precisely what we get. So that's our answer, D. Let me just take it right, D. All right, the next problem is question 18. It says calculate the number of revolutions a bicycle wheel with radius 35 centimeters will make in order to cover a distance of 330 meters. Now we have to remember that one revolution, if you have a circle or a bicycle wheel, one revolution is the same as, or the distance it will cover in one revolution is the same as the circumference. One circumference. So we need to find the circumference of the circle, and the circumference, the formula is 2 pi r. So we have 2 times pi, which in this case is 22/7, times r, which in this case is 35 centimeters. Here we have to be careful of the units, so let me write the units. So what is this equal to? Well, we can cancel 7 to 35, we get 5. So we have 2 times 22 times 5. 2 times 5 is 10 times 22, that's 220 centimeters. And now we want to cover a distance of 330 meters, and we want to know how many revolutions do we need. Let's first convert the 330 meters into centimeters. So 330 times 100 centimeters, and we'll divide that by 220 centimeters. So now we can forget about the centimeters. We can divide this by that. If you divide both by 110, you will get that, and then you have a 2 here, you divide that, you get 50. So this gives you 150, and that's our answer. The next problem is question 19. We're supposed to simplify this fraction. We can write it all over one denominator, so let's write it all over 18. And then how do we write this first one? 2 divides 18, 9, so we get that 2x plus 1 minus 2 into 3x minus 7 minus 5. So simplifying further, we have 18x plus 9 minus 6x plus 14 minus 5 all over 18. Then we have 18x minus 6x, that's 12x. Then we have plus 9 plus 14 minus 5, that's 18, plus 18 all over 18. Then we can divide through by, let's say, 6. So when you divide 12x by 6, you have 2x. When you divide 18 by 6, you have 3. And then when you divide the denominator also by 6, you get 3. So we have 2x plus 3 all over 3, and that's D. The next question is question 20. It says if tan x equals 1/3 and x is between 0 and 90 degrees, so x is an acute angle, evaluate 2 cos x. So here we will use SOHCAHTOA. SOHCAHTOA. And we are dealing with tangent here, so we are interested in the TOA. That's what we're going to use. This means that the tangent equals the opposite over the adjacent. So if this is x, then if tan x is 1/3, it means that the opposite 1 is 1 and the adjacent is 3. And we have a right angle triangle, so we can find the hypotenuse. Now we want to find 2 cos x, and to find cos x we use CA, which is the cosine is the adjacent over the hypotenuse. So it's this 3 over whatever the hypotenuse is. So we need to find the hypotenuse, and the hypotenuse is the square root of 1 squared plus 3 squared, and this is equal to the square root of 1 plus 9, which is 10. So cos x, or if you will, 2 cos x equals 2 times the adjacent, which is 3, over the hypotenuse, which is the square root of 10. Simplifying further, we get 6 over the square root of 10. Now we can rationalize by multiplying both the denominator and the numerator by square root of 10. So let's do that with a different color. Square root of 10 over square root of 10. Now 6 times square root of 10 is just 6 times square root of 10. But square root of 10 times square root of 10 is 10. So we have 6 times square root of 10 all over 10. But we can simplify further. 6 and 10 have a common factor of 2, so we can divide both by 2. If you divide 6 by 2, you get 3. If you divide 10 by 2, you get 5. So we get 3 root 10 over 5. And that is D. So that's our final answer. So that brings us to the end of this video, where we've solved questions 11 to 20. We're going to solve the remaining questions in the subsequent videos. See you then. Bye.